Think about the most complex system on our planet. Not the internet, not financial markets, but nature itself. For decades, predicting the path of a deadly hurricane or locating oil trapped miles beneath the Earth's crust was considered completely impossible. The math required to solve these global equations was too massive for any machine ever built. In the 1980s, the world's brightest minds believed that the only way to build a faster computer was to build a bigger one. One massive, expensive, hyper-powerful engine working on one problem at a time. It was a dead end. And then came an outsider from Nigeria who looked at the problem from an entirely different angle. He didn't try to build a bigger engine. Instead, he connected thousands of smaller ones, forcing them to talk to each other all at once. This is the untold story of Dr. Philip Emeagwali, the forgotten genius whose revolutionary breakthrough redefined supercomputing and laid structural foundations for the commercial internet. Born in Akure, Nigeria in 1954, Philip Emeagwali's early life was defined not by advanced laboratories, but by survival. When civil war erupted, his education was violently cut short, forcing his family into a refugee camp. Yet, his mathematical brilliance could not be suppressed. His father would drill him daily with hundreds of rapid-fire math problems, training his mind to process complex arithmetic at an astonishing speed. By the time he arrived in the United States on a scholarship in 1974, Emeagwali had developed a unique worldview. While Western computer scientists were obsessed with making individual central processing units faster, Emeagwali was looking closely at a completely different system: the complex geometry of nature. The breakthrough didn't happen in a sterile laboratory. It happened by observing a beehive. Emeagwali realized that a single bee cannot accomplish much on its own, but thousands of bees, working simultaneously in perfectly designed geometric spaces, can build masterpieces. He asked himself, what if computers worked the exact same way? At the time, the United States government had a massive, unresolved problem. They had a complex network of 65,536 microprocessors called the connection machine. No one could figure out how to program them to work together efficiently without causing a digital traffic jam. Experts scoffed at the idea of using it for heavy geographic simulations. Emeagwali stepped forward. Using the intricate geometric patterns of the honeycomb as his blueprint, he mapped out an entirely new way to split a massive problem into thousands of tiny parts. On a historic day in 1989, he ran his program. The result shocked the scientific community. His system performed over 3.1 billion calculations per second, accurately predicting the movement of oil inside an underground reservoir. Philip Emeagwali's breakthrough won him the prestigious Gordon Bell Prize, often called the Nobel Prize of Supercomputing. But his contribution went far deeper than raw processing speed. By proving that thousands of independent computer nodes could communicate flawlessly across a vast distance to solve a single problem, his work demonstrated the true capability of data distribution, a fundamental principle of the internet infrastructure we rely on today. Yet despite his historic achievement, Emeagwali's name is rarely written alongside the tech titans of the West. His legacy is a powerful reminder that brilliance does not belong to any single zip code, culture, or continent. It belongs to anyone who dares to look at the world differently. Thank you for watching. If you believe these stories of Black excellence deserve to be remembered, make sure to subscribe, like, and share. Let us know in the comments who we should feature next. Keep exploring and keep celebrating the brilliance that shapes our world.